This video lecture is meant to cover the information found in Section 1 of Chapter 8. This is our first video lecture in Unit Number 8 on covalent compounds. This section covers Objectives 2, 3, and 4 on your unit objective sheet. Starting out with trying to understand the definition of what is a covalent bond. We've seen in Unit 7 that ionic bonds form when a metal atom gives its electron to a non-metal atom, and they don't share electrons. One electron is actually given away to the other atom. In a covalent bond, two electrons are shared between two atoms, and the octet rule still applies because each atom that's sharing the electrons is sort of tricked into thinking that it has a full valence shell. Right? So that's the goal, is to try to get that full valence. And covalent bonds help form compounds with distinct molecules, whereas in the ionic compounds, there was sort of a grid, an array of ions that were in this fixed matrix, whereas in a covalent bond, molecules are formed, and the molecules are essentially free-floating from the other molecules. The video that you see here is a continuation of a video that you saw in the last unit, and here it is picking up talking with how covalent bonds are formed.
Covalent bonding occurs when neither atom has sufficient strength to completely remove the other atom's electrons. The atoms share electrons, and both atoms achieve a stable outer energy level. A hydrogen atom with one valence electron needs one additional electron to complete the first energy level. An oxygen atom has 6 valence electrons and needs 2 additional electrons to complete the second energy level. As the oxygen and hydrogen atoms collide, covalent bonding is accomplished by the sharing of electrons. By sharing an electron pair with the oxygen, the hydrogen completes the noble gas configuration of helium. By sharing with the hydrogen atom, the oxygen atom now has 7 electrons in its energy level, still one short of the stable octet condition. A stable octet for oxygen can be completed by sharing an electron with another hydrogen atom.
So that animation is meant to show you what's happening on the atomic level. Let's take a look here, and we'll see it on a regular scale. In ionic bonding, we saw that there were metals and nonmetals that reacted together. In this unit, in covalent bond formation, typically you see nonmetals bonding together with each other. Metalloids can also participate, but by and large you're going to see mostly just nonmetals participating in covalent bonds. This video is going to show you the reaction of hydrogen and oxygen, like the video you just saw that showed you the atomic level of the electrons sharing. This is going to show you the actual reaction of hydrogen and oxygen, which forms water.
Water is an example of a compound containing 2 oxygen-hydrogen covalent bonds. Hydrogen is a colorless, explosively reactive gas. Its atoms have 1 valence electron. Oxygen is a colorless, reactive gas. Its atoms have 6 valence electrons. When the 2 gases are mixed, a spark will cause them to react. The atoms explosively combine as a pair of electrons become shared between each oxygen and 2 hydrogen atoms. A closer inspection of the inside of the container shows water vapor condensed on the cool container walls. Here is the same reaction in a different setting.
So here you see a video footage of the Hindenburg Zeppelin that burned back in the 1930s. It used to be that blimps were filled with hydrogen gas instead of helium. Hydrogen is much more buoyant. I think it's 4 times more buoyant than helium. Of course, the problem is that hydrogen is flammable, and with that spark igniting the hydrogen, which then caught the skin of the blimp on fire and ended up in that horrible disaster that you just saw. Molecular compounds. These are compounds that contain covalent compounds, and the definition is that these are compounds that contain nonmetals, and those nonmetals are connected with or connected by covalent bonds, sharing of electrons between two atoms. Their properties: they have a low boiling point and a melting point. This contrasts with ionic compounds that have a very high boiling point and a high melting point. And molecular compounds tend to be either gases or liquids at room temperature. Sometimes they are solid, so these are kind of all over the map. Some examples here: this is water, H2O, which is a molecular compound, and at room temperature it is a liquid. Carbon dioxide is a gas at room temperature. And then there are things like sucrose, table sugar, which is a solid at room temperature. So there's a lot more variability amongst the molecular compounds, amongst compounds that are covalently bonded. Now, molecular formulas, structural formulas, and 3D drawings are all different ways to represent covalent compounds. Each one conveys a slightly different amount of information. So we're going to just take a quick look and see what information can be had. CH4 right here, this is an example of what is called a molecular formula. What you see in this formula is what elements are present. We see that this has carbon and hydrogen, and we see how many atoms of each element are present. There are 4 hydrogens to every carbon. Now, it doesn't tell you the arrangement of atoms, but that's what structural formulas are handy for. This shows you that there's the carbon is at the center of the molecule, and that the 4 hydrogens are radiating out from that center atom. So we see the same information that a molecular formula gave us, what elements are present and how many atoms of that element, but we also see the arrangement of the atoms. Then there are 3-dimensional drawings and ball and stick models that can take that information and give you a little bit more detail. You can still see here from this ball and stick model or this 3-dimensional drawing what elements are here and how many atoms, but we also see not just an arrangement, but more of a 3-dimensional arrangement of the atoms. At least a 3-dimensional arrangement as best you can on a piece of paper. So this ball and stick model is like what you would build with the model kits. This is a 3-dimensional drawing that is meant to show you that this hydrogen is coming out in space towards you. This hydrogen is going away in space, away from you, and as is this one. And this straight line going up shows you that the hydrogen is going straight up from the center carbon. Now, covalent bonds are always when you have 2 shared electrons. That's what we call a single bond, and that's represented here by the H connected to the Cl right here. That dash right there is what we call a single bond, and that bond contains 2 shared electrons. That's a covalent bond. You would rewrite this as Cl-H if you were just writing this out on a piece of paper. You wouldn't necessarily try to draw it 3-dimensionally. Now, if you have 2 pairs of shared electrons between 2 atoms, here we have a C double bonded to an O. Each one of these lines right here represents a pair of shared electrons. So collectively, this is a double bond, and over here is another double bond. So it's a total of 4 electrons being shared between 2 atoms. Then we have what are called triple bonds, where each one of these lines represents a pair of shared electrons, but because those 3 pairs of shared electrons are being shared between 2 atoms, that is called a triple bond. We would rewrite these a little bit differently if you were just to write them out in terms of structural formulas. The C double dash O, and then this molecule here, which is acetylene, C triple dash C, and then a single, whoops, this should be a hydrogen right here. Let's fix that. So this is acetylene gas that welders use in their torches. The last thing we're going to talk about in this section of this video lecture is what are called the 7 diatomic elements. Diatomic, di meaning 2, atomic referring to 2 atoms. There are 7 elements that when they exist in their elemental form, they are not monoatomic. They exist in pairs. So for example, you know many of these. Hydrogen is H2. You would draw it as a structural formula, H-H. Oxygen, when it exists as pure elemental oxygen, it is O2. That has a double bond between the 2 oxygen atoms. Fluorine gas, this one you might not know off the top of your head. Fluorine gas is F2 and it has a single bond between them. Br2 is bromine, the liquid, and it has a single bond between them. Iodine, which is actually a solid at room temperature, it exists as purple crystals. It has a single bond between 2 atoms. Nitrogen, N2, has a triple bond between the 2 atoms. And Cl2, which has a single bond between them. So there's a couple ways that I'm going to help you remember that these 7 elements, if you're going to write them out all alone in their elemental form, not combined with any other element, you have to write them with a 2 as a subscript. You can remember this by the acronym Hofbrinkel. The elements sort of spell out a funny word, Hofbrinkel. Or on the periodic table, some of these elements actually form the number 7 over here, but you also have to remember that hydrogen is one of those elements. So this one's kind of nice. There's 7 elements that do it, and it forms the number 7. Kind of clever. Alright, this concludes the video lecture from Section 1 of Unit 8. See you in the classroom.